Hello, thank you for joining me. So in this video I'd like to show you how to model a reasonable representation of a switch plate, something you would normally see in a residential application in a house here in the United States. And it's going to be kind of a modeling exercise. I'm going to be showing a lot of things that are going to be associated with modeling, getting a good basic sketch geometry down, and showing you some of the bells and whistles that are associated with that, including sketch relations and dimensions, and the choice of whether putting all these sketch elements into one sketch or to divide that up amongst different features. But this is what we're going to be doing ultimately. This is going to be a switch plate. And what we can do is we can take with this existing switch plate, we'll start from the very beginning here in just a minute, we can take a rollback bar, which is this item down here in the bottom, and that's a test question, by the way. What does that do? The rollback bar allows you to go back in history in the model and be able to see some of the things all the way back to where you began, or anywhere in between the model. So we're going to go back to our basic extrude and take a look at that. And we're going to take a look at the sketch associated with that, and just kind of go through this model piece by piece, and maybe talk about it a little bit. So the basic dimensions, the basic geometry here, is going to be 4.5 inches by 2 3/4 of an inch in regard to these dimensions. And then we're going to talk about the sketch relations here, but that's going to be our basic extrude. And yeah, let's go ahead and go to our feature and take a look at that and see how thick it is. So it should be 0.2 inches, not 0.19 with some change after that. You want to make sure that you don't have dimensions that go out to like 8 or 10 significant digits there. It might slow your model down when you do that. But I think it's 0.2 inches, and you also want to make sure that when you do extrude it, that you're extruding it in the proper direction. So from the very beginning, you want to make sure that you know what the orientation of your model is going to be. And with the switch plate, when you're looking at it in this orientation here, you want to make sure that you're probably on the front plane. So you're looking actually at the front rather than the top or the right side of that. And then when you extrude this, we're not going to do a mid-plane extrude in this, but we could. But in this respect, if you think about the plane of the wall, where the drywall is, and the pane on top of that, you can consider that as being also the front plane, and we're actually extruding that switch plate from that plane. So we're going to go out 0.2 inches blind in that one direction, which is coming out towards us in the z-axis. You can see that down here. So that's our base. And if we go back to that sketch too, you can see that we've just done the basic sketch here for that particular feature. But there is another way of doing this, is you can take all your sketch elements and put it in one place throughout all the features that are going to be associated with this. You have kind of like a one-stop stopping sort of thing. One-stop shopping sort of thing, where all of your sketch elements are in one sketch for a number of different features. And I'll show you that when we get around to doing that. So the second thing I did was to put in a chamfer. Now it's 1/10 of an inch, or 1/8 of an inch at a 45-degree angle. And that's our chamfer, and what we did is we chose selections all the way around our, the perimeter or the top part of that plate. It's a good idea to also name your features as you go. That way when somebody else is working on your work, or maybe you're working on your work, or I'm working on it, I can find my way around, and you can find your way around too. So the hole cut in the back, we have a sketch that's associated with that too. So that's going to be 4/10 of an inch by 1 inch. There's going to be a hole right in the middle. So what you see in here, if you recognize this, you see a center rectangle. And I also have put in some points in here too. These points are going to be associated with, ultimately, a hole wizard hole that we're going to put in here that's going to help drive our design. So in a way, this is one of those one-stop shopping sort of scenarios, where we're going to put in the reference geometry that we're going to be using for our hole wizard for. We're going to be using that reference geometry in there in order to define those points. So let's go ahead and rebuild that. The rebuild button is right up here in the top. It looks like a traffic light without the yellow light. And what that does is it rebuilds your model. So it takes you out of the sketch element and puts you back into the feature, and eventually back into the part that we're doing here. So every time you're in the middle of the sketch making modifications to it, if you go to the rebuild button, it takes you into the feature, into the part, depending on where the rollback bar is. So let's scroll down a little bit more. This is our hole wizard feature. You'll notice over here in the Feature Manager Design Tree some of the different symbols are associated with the different features that are in the Feature Manager Design Tree. They're all different. You have a basic extrude symbol, you have an edge chamfer, or a chamfer symbol over here. We have our hole cut, and then we have our hole wizard. And it's got a little magic wand that's associated with that, kind of cute. And the hole wizard feature is, it has two sketches in here. We'll talk about this here in a little bit. But we have one sketch, which is the actual location where that hole is going to be, and then a sketch that defines the revolve feature associated with that hole. So if you look at that from the side, it's got some very specific parameters to it. 100-degree angle, almost a third of an inch across in diameter on the top, but down to 0.177 inches in diameter when you actually get to the hole, and so on and so forth. And what that does is it takes that profile and revolves it around at the location in sketch number 5. Then we're all done with that. If we look at the back here, it's just a flat plate back here, particularly to hollow it out to provide with less material when you're actually putting your part together, and it makes for a much better design. When you're doing plastic extruded parts, you've had a very consistent wall thickness to it. The parts will probably come out with a lot more in the way of integrity and a lot fewer gaps and warpage that might come from that. So typically what you do is you shelve it out, and we have another feature in here which allows us to do that. So here's a shell feature, and what we did is we chose a face, just this back face back here, and what it does is avoid some of these cuts in here, and it puts a thickness in here all the way around. So this element here, again, out to 8 significant inches probably isn't appropriate, but maybe 1/10 of an inch would probably be good. And that actually looks a little bit thick, so let's right-click on that and actually make that a little bit less, maybe 0.05 inches, and see what that looks like. That looks like it's in much better shape. So that's probably an appropriate thickness. Again, we'd probably have to take a switch plate apart and maybe look at that a little bit closer and see what the actual thickness of that might be. I don't think there's any real standard for that. It's probably driven by the plastic involved and how quickly they want to be able to mold this. And you're probably going to find a whole bunch of different standards out there. But this looks reasonable. Again, this is just a reasonable model, strictly designed to get you started in SolidWorks and show you some good basic sketch geometry that's going to help define this whole model. So with the back shell there, the last thing we want to do is put a rib in, and what that does is going to help strengthen the walls here a little bit. That is also 0.05 inches, 50 thousandths of an inch thick. And what it does is it provides a little bit of thickness, a little bit of bossing around here in order to make for a more of a I suppose a stronger model when it comes to actually installing this. A lot of times you will see these ribs between the screw holes and the opening where the actual switch is going to come out. It's less common to see them over here, but it does add strength and stability to your model. If you're wanting to do so, you can probably add a rib to the top, or between that hole in the bottom and between this hole and the top up here. So that's our model. We're going to go ahead and start sketching this in our second video. So we will look for you there.